we're discussing triangle similarity. We're going to try and find what information about sides and angles of two triangles allow us to conclude that triangles are similar. We're trying to prove certain triangles are similar by using AA, SSS, and SAS. Now, some of you are desperately wondering what AA stands for. It does not mean double A batteries. It does not mean Alcoholics Anonymous. Okay? It actually means the angle-angle similarity postulate. Okay? Angle-angle similarity postulate. You need to write this part down. Angle-angle similarity, and then write down the postulate. You also need to write down the triangle sum theorem. Okay? Write down those two pieces of information. The angle-angle similarity postulate and the triangle sum theorem. Okay? We have several ways that we can prove the triangles are similar. The angle-angle similarity postulate and the side-side-side and side-angle-side similarity theorems will be used in proofs, and then when we get to congruence, we're going to have side-side-side, side-angle-side, side-angle, side-angle, side. Well, we don't say those for a rainy day, okay? All right, guys. Real quick, while y'all writing that down, y'all know about attending school and how important it is, right? Okay. Make sure, remember, you get 4 absences, unlimited medical excuses, 3 days for parent notes. If you have more than 3 unexcused absences, and that's a failure, you get 2 tardies and 1 unexcused absence. All that good stuff. Right. Everybody's doing the right thing. Keep coming to school no matter what. Okay? If not, be back here again next year. The government will find you. All right, here we go. Angle-angle similarity. Let's go over it real quick. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Right? If 2 angles in one triangle are congruent, meaning the exact same, identical, to 2 angles in another triangle, then the 2 triangles are similar. Now I added this, the triangle sum theorem in here, to make sure we get this down. Okay? Triangle sum theorem might be one of the most important things that we learn all year. All angles of a triangle have a sum of 180 degrees. All angles of a triangle have a sum of 180 degrees. Okay? All right. How many angles are there in a triangle? Cameron. 180. How many angles are there in a triangle? 3 angles in a triangle. Okay, for something to be a triangle, the 3 angles have to add up to be 180. Okay, you got me? So check this out. If we went 90, 89, and 1, 90 plus 89 is 179. 179 and 1 is 180. Does that work? Sure. Yeah, absolutely. Okay, it wouldn't look like that, but it would work. If we went 100, 100, and 100, would that be a triangle? Nope, sure wouldn't, dog. Okay? Does not classify as a triangle unless the interior angles are 180 degrees. They have a sum of 180. All right? Y'all good with that so far? Okay, so check it out. Yes or no? Is these particular triangles, triangle ABC, is it similar to triangle DEC? Okay, check it out. Okay, watch me go over this. What we know right now is that if there are two different pairs of congruent angles and 2 triangles, those triangles are similar. Let's look at triangle ABC. Okay? Angle A is how many degrees? Right. Stop in that. Angle A is 90. Notice 90's got the box. Angle B has a ring with it, right? Okay? That's key. Here's why. Angle D is another box. That's 90. Angle E has a ring with it. Those rings mean congruence. Okay? So I've got a 90-degree angle and a congruent angle. I've got a 90-degree angle and another congruent angle. How many different angles in those two triangles are congruent? How many? 2. Is that good enough for my angle-angle theorem? Yes, yes. Angle-angle theorem. How many angles must I have? 2. Okay, y'all got me? 2. All right, let's do a quick little recap here. If I said the only thing that's equal is angle A and angle B, and that's it. How many pairs of angles are congruent? 1. Is that good enough for the angle-angle theorem? No. There's a reason I keep saying angle-angle. Angle and then angle, right? You gotta have at least 2 for that to be true. Okay? Everybody with me so far? We'll catch on here. We'll catch on. All right. Here we go. Let's try this one. Okay? Let's try this one. First off, Ethan. This is a triangle. How many degrees are in this triangle? Very good. Ethan, how many degrees are in this triangle? Perfect. Ethan, you're the only person in my 3 blocks that's gotten that right, okay? Somebody insisted there were 43 degrees in this one and 47 degrees in that one, but that's not true, right? Okay? Now watch how easy this can be. Ethan, if I said, what's the measure of angle C? Realize you can do this. Take 180. And from what else? 90, right? The right angle is 90. So use your calculators. 180 minus 43 minus 90 is what? All righty. 47. So this is now 47 degrees. Whoa. Okay. Now all of a sudden, how many pairs of congruent triangles or congruent angles do I have? 2, right? See it now? No. Yep. This angle, angle C, and angle F are now congruent. They are both 47 degrees. Okay? If I kept going with this problem, I would tell you 180 minus 47 minus 90 is 43 degrees. Watch all. I've got 2 pairs of congruent angles. Okay? Watch how I write this similarity statement. This is important. Mr. Foster, don't miss this. Triangle ABC. Triangle ABC. How many degrees is angle A? 40 what? 43 degrees. 43 degrees. How about angle B? How about angle C? Okay, is similar to, and watch how this has to be written. In this triangle, which one was 43 degrees? Triangle B, what was 90 degrees? How about 47? Okay, you see how the angle measures have to be the same. Order matters in these 2 triangles, right? Notice I did not call this triangle FED. That's not correct. That is incorrect. If I start with 43 degrees, start this side with 43 degrees. Okay? I started with 90 degrees. Let's say BAC. Here we go. EEF. Right? You got me? It's a fickle thing, geometry. Right? Fickle. That means fickle. It means that like so nitpicky. cousin is like driving crazy. Why? Every time they talk about me, they come up to like, oh man, you haven't brushed your teeth in a while. Yeah, I brush them every morning. Yeah, but that's not a wow. Okay. Oh wow, you get your clothes at like a store. Yeah, yeah, I do. Oh, okay. They're not hand-made. Well, I don't know. You can't take some by hand, but I just put them on the store. Oh, right. Gotcha. Okay. Right. Fickle. Okay. That's my definition. Okay. Fickle is no, not at all. Fickle. The details matter. It has to be precise. All right. A couple more things for y'all to write down. Write down side similarity, side similarity, and the theorem. Write down side angle side and the theorem. Okay, please write both of those things down. You don't get here. My side similarity theorem says if the three sides of one triangle are, there it is again, proportional to the three corresponding sides of another triangle, and triangles are similar. Okay, that's simple, right? Pretty simple. Okay. Let's see. Let's flesh this out a little bit. Let's say A to B is 2, B to C is 4, and A to C is 6. Right? Well, if D to E is 4, E to F is 8, and D to F is 12, I have proportionality among those three sides, correct? Yes or no? What is my proportionality here? Cameron, what is 4 over 2? What? 4 divided by 2. 2. Thank you, Cameron. Cameron, 8 divided by 4. No, Cameron, it's 2. Cameron, 12 divided by 6. Don't miss this. 2. Thank you, sir. Okay? So, I have my ratio. I have my proportionality there, right? If the three sides are proportional to each other, even without knowing anything about the angles, you'll be able to conclude that the triangles are similar, okay? Watch how fast I can mess with your mind here. Coach, you ready for this? Those got me similar. They got me. Cameron, what is 10 divided by 6? You use your calculator. Yeah, as a decimal, that's what? This is not a, okay, this is not a trick question. Is 2 the same as 1.6? Is 2 the same as 1.6? No, it is not. Okay, so even if one side is off, even if one side is a little bit off, do not take the bait. Okay? The bait is, oh yeah, they're so close to being similar though. They're so cute, they look good together. Don't take the bait. Okay. All right. Next, I got the side angle side similarity. If two sides of one triangle are proportional, I should say the proportion to two sides of another triangle, and their included angles are congruent, then the triangles are similar. What? Included angles being congruent? What? Coach, included angle? All right, let's see if we can do this. Just got a text message. Nobody looked. All right, so included angle, okay? Y'all listen up. Included angle means the angle that lies between the two proportional sides. Another way of thinking about it is this. If I took AB, line segment AB, right? You got me? Line, remember that first day? Line segment AB. and then I took line segment CB. What angle would those form? What angle would that form, guys? What does it say louder? We're back in there. It's B. Angle B is formed. An angle is when a line segment, or a ray intersects or meets another line segment, or ray at a point. I have said that, right? Okay. All right, good. Okay. This is an included angle here. Let me give you what an excluded angle would be. If ABC is my angle, C is excluded. You know what it means to be excluded? You're not invited to the party. Okay? You don't get to join. You don't get to tweet. You don't get to Snapchat. You don't get nothing about it. You're out of the deal altogether. I'm not saying about you. I'm just saying that. Okay? That's what it means to be excluded. It means when cool stuff happens, you're not there. All right, let's do a couple of these. Check it out. Verify these triangles are similar. What theorem would I use? I don't know why people aren't looking up here at me. I really have no idea why. It's not been that long, 15 minutes. Okay? It's not been that long. This is important stuff. All right. Off the bat, let's just take a ponder here at what I should use. I've got 3 different theorems. Angle, angle, side, 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 and side, angle, side. So let's see here. I'll call on you. Okay? Gavin? Which one of these 3 theorems do you think I'm going to use here? Why would you say side, angle, side if I haven't given you a single angle? I'm looking at these triangles too. Do you know that any of these triangles are congruent? Don't tell me they look the same. Just the part where you say, what information have I given you here? 3 sides, right? 3 side measurements. And which one of our theorems does 3 side measurements? Side, side, side. I picked on him because all of y'all were thinking that same thing. Okay? All of y'all were thinking that same thing. All of whatever. All right? Now, guys, think about what I'm giving you here. I've given you sides, 3 sides of the triangle. Okay? You're going to be proving or disproving it through side, side, side. Look how we do this. We set it up as a proportion. P to Q is 3, S to T is 4.5. That simplifies to 2/3. Q to R is 3, T to U is 4.5. That simplifies to 2/3. P to R is 2, S to U is 3. Don't even have to simplify it. It's already 2/3. Do I have proportionality among the 3 sides? Come on. Yo necesito hablar en español. ¿Por qué? Porque los estudiantes se aprenden más. ¿Aprendes más en español? ¿Sí? ¿No comprendes más en español?
No speaking Spanish.
Guys, the 3 sides, do they have the same similarity ratio? I know what we're going to figure out now. All right? All right. Yes, they have the same similarity ratio. Similarity ratio is 2/3. Okay? 2/3. They all have a ratio of 2/3. Okay? Gavin. I'll go back to your question here. Say I had taken out this side, and I take out this side. Okay? All right. Now, I give you this information. Which of my theorems do you think I should use in now? side angle side's correct, right? Now look what he did there. He said, I want to say side angle side. Probably because I took out one of the sides and gave an angle, right? Not only that, I gave an included angle, okay? Included angle, meaning, you see how I gave you R to P and P to Q? I gave you those side links. That means that I need to give you this angle measurement, angle P, okay? I need to tell you that that one is congruent. That is how I would prove side angle side. Proportionality on the sides with an included congruent angle. Right? So we did what? Side, angle, side. Right? We got side, angle, side. Okay? Alright, now let's make sure we're clear on something. Okay, let's say here's the information I give you, Gavin. Here and here. Yes or no? What would that tell me? What? How many angles did I give you? In this triangle, how many angles did I give you? One. Remember, each triangle, okay? Each triangle, it's 2 points. One angle, side to side. Correct? Is that what I need? All right, ready? Here's the mistake we just made. Okay, coach? We did this. We did angle, side, side. Did I write it out again for you? You did angle, side, side. Okay? What happens when you put together angle, side, side? Yeah. I'm going to tell you. Yeah. Okay? This is called excluded, right? Yeah. Y'all see this? This is excluded. This is an angle that is not between my proportional sides. Okay? Got me? I'm going to give you some life principles here. Here's some life principles. You can chase it. Okay? You can pay for it. You can twerk it. All right? You can look at it. All right? You can work it. All right? You can grow it. Okay? You can get it. You can keep it. But you cannot prove similarity through it. All right? Y'all got me? It's real simple principle. Okay? Very simple. All right? I don't tell you what to do with yours. You don't tell me what to do with mine. All right? And one thing you can't do with mine is prove similarity using angle side side. Oh, yes, ma'am. Very good. Yes, yes. So watch this, Camry. Even though this is an excluded angle, okay? Even though this is an excluded angle. See that? How many different angles do I have now? 2. So if I came over here and I gave you that right there, even though they're excluded, it's okay. All right? Once I hit those magic numbers, 2 angles, I'm good. All right? Good question. Anything else that you want to ask me? No? No other questions? Good deal. All right. One more set of notes. This is it for today. Okay? I want you to make sure you write down this part right here. The reflexive property of similarity, the symmetric property of similarity, and the transitive property of similarity. Write those 3 things down in your notes. We'll be done here in just a second. Why aren't you writing this down? Do not get your angle side sat down too much. All right, the reflexive property. I'm going to talk about these things real quick. They're not that bad. Y'all look at this blue triangle here. I've labeled it A, B, C. See that one? Now watch this. I'll let this red triangle. I'm gonna label it A, B, C. Yes or no? Triangle ABC is similar to triangle ABC. Yeah, it has to be. They're identical, okay? The reflexive property is identical. Okay? Let's see here. Here, stand up. Stand up. Come on. You too. Come on. Come on. Come here. All right, let's show the reflexive property. Come here. Come here, guys. Come here. Come here. All right, let's go over here. Michael, Lucas, Ethan, right? Correct? Close enough. All right, y'all see that? Okay, sit down. Thank you. All right. All right, here we go. Briar, Doofus, Alyssa, right? What was the same in both of those? Dude, me, right? Y'all. Absolutely. Okay. Y'all see how I did not change, right? I did not change in either of those examples. In the same way, if I did this to you, let's say I said, hey, there's another triangle here, A, B, F. In the, let me do it like that. Let's do it like that. Where the green triangle, A, B, F. Ethan, have a seat. I'll sign it one of those. Okay. All right. Now, you sit down. Let's find angle A. Okay. Angle A, and the blue angle A is the same as the red angle A, is the same as the green angle A. Okay, that's the reflexive property. My symmetric property simply says this. Let's say I take this, say I take a triangle down here. I call it D, E, F. Okay, I know it's not the same. Watch this. Triangle ABC is similar to triangle DEF. Pretend like it is. Okay? All right? The symmetric property says, well, genius. Then triangle DEF is similar to triangle ABC. See what I did? ABC is similar to DEF. Well, if that's the case, then DEF is similar to ABC. It's like, nah, duh. Okay? Y'all did this. Sometime in, I don't know, Coach, when they do algebra, fourth grade? Okay, you started off and y'all had to solve for X sometime, way a long time ago, right? And probably 7th grade, 4th grade, whatever. Okay? And probably one of your teachers sitting there and they're like, your variable always has to be on the left side. That's a rule in math. It's always got to be on the left. If it's not on the left, I'm going to count it wrong. And you could invent a time machine and go back to that 4th grade teacher or 7th grade teacher and slap her in the face and say, no, ma'am, there's a thing called the symmetric property which says that it don't matter if your variable's on the right side or on the left side, it's the same either way. Okay? It's called the symmetric property of equality. We have a geometric property, the symmetric property of similarity. Okay? It doesn't matter one way or the other. It's going to be okay both ways. All right? Last one I have for you is called the transitive property. You hear transitive, think of threes. Okay? Here it is. If ABC, triangle ABC is similar to triangle DEF, and if triangle DEF is similar to triangle XYZ, Watson, triangle ABC is similar to triangle XYZ. If 1 is to 2 and 2 is to 3, then 1 is to 3. Okay? 1 is to 2. If 1 is to 2 and 2 is to 3, then 1 is to 3. Cameron, if 1 is to 2 and 2 is to 3 and 1 is to 3, is 3 to 1 through the transitive property? No. All right, that's all I got for you guys today. Does